Okay, students, if you have not subscribed this channel, please click on subscribe button and also please share the information to all your friends. Voltage division rule. You can also watch all the previous session just by click on the playlist. Okay, voltage division rule. Whenever the elements are connected in series, then only this rule is useful. Why? Because in the series only voltage is divided. Current is same now. In the series connection, current is same. Voltage only divided. So note down that point. Series connections. Voltage is divided. Current is let us take first of all resistors. If R1 R2 are connected in series, then if you are going to apply the voltage, this voltage will be divided as per the resistances. Here V1, here V2. Okay, we know very well as per the Ohm's law, V is equal to I into R. In the series connection, I is the same. That means as I is same, V proportional to R. That means the voltage across the resistor will be depends upon the resistance value. Higher the resistance, higher the voltage drop. Okay, so directly proportional. So in this case, if you can consider the current I is equal to voltage by total resistor 1 plus resistance 2. If I of the current is flowing here, okay, then voltage across V1, voltage across R1, that is V1 is equal to current is same and that resistance I into R1 na. So I is nothing but V by R1 plus R2 into R1. So finally what you are getting? The total voltage into that corresponding resistance by total resistance. Okay, so that means you can write down the formula. Total voltage into same resistance by sum of resistances. Okay, all of you getting? The simple formula is total, that is the voltage across any element is equal to total voltage into the same resistance, that corresponding resistance by sum of the resistances, that is R1, R2. So V, total voltage V into R1 by R1 plus R2. Okay, in this way you can find out the voltage across any element. If you find out voltage across V1, then V2 is nothing but V minus V1 only. So directly you can get. Okay, or otherwise you can write down for V2 total voltage V, same resistance R2 by total resistance R1 plus R2. Like that you can write down the voltage division rule. Okay, the same voltage division rule for inductors also same. If you can consider inductors, L1, L2, if you apply the total voltage, it is the V1, it is the V2. V1 is equal to total voltage into same inductance by total inductance. V2 is nothing but total voltage into the same corresponding inductance by total inductance. But coming to the capacitors, different from resistor formulas. Okay, so if you have the capacitors are connected in series, C1, C2, okay, the voltage across C1 is V1, voltage across C2 is V2. If you apply the sum voltage, it is total voltage V. Okay, so that is nothing but voltage across C1 or VC1 is equal to, here total voltage into another capacitor value by sum of capacitances. Okay, so that means VC1 is equal to total voltage V into another capacitor C2 by C1 plus C2. Okay, so that means formulas are different. Let us take VC2 is equal to total voltage into another side capacitance C1 by C1 plus C2. Okay, so like that we have the difference from the resistor formulas for this capacitance. Okay, so in the previous resistor case, same resistance by sum of the resistance. Here another or opposite capacitance by sum of the capacitance. Okay, now coming to the current division rule. In the same manner, current division rule. Okay, in case of this current division rule, we know very well in parallel connection current is divided. Parallel current is divided. Voltage is same. Okay, voltage is same. If we have two resistors are connected in parallel, first of all I am giving about the resistances. R1, R2. Okay, if it is a total current I, it is the IR1, it is the IR2. Okay, IR2. So here the current through any one of the resistor is equal to total current into another resistor by sum of resistance. Why we are going to another? That is nothing but we know very well V is equal to I into R, I is equal to V by R. If the V is same, I is inversely proportional to resistance. So that's why we have to take another resistor by sum of the resistance. Okay, so that is IR1 is equal to total current I into another resistance, that is R2, by sum of the resistance R1 plus R2. In the same way, IR2 is equal to total current into, if you got one, other one no need to find out. Okay, just subtract from the total, you will get the answer. R1 by R1 plus R2. Okay, like that we are doing. Inductance formulas are same as resistance. Now coming to the capacitance. Capacitance formulas are different. Different from resistor formulas. Okay, so if the capacitance are connected like this, C1 and C2, it is a total current, it is the I1, if it is the I2. Okay, so the current through the capacitor 1 C1 is equal to total current into another, here we have taken for resistor another na, so for the capacitor we have to take the same total current into same capacitance by C1 plus C2. And coming to the I2 is equal to total current into same capacitance by total capacitance C1 and C2. Okay, these are the formulas we have for the capacitor in current division rule. Okay, current division rule. Let us take some values, then you will get the idea. Here let us take, it is a 2, it is a 4, capacitance values are 2 and 4. Let us take the total current is nothing but let us take 6 amps. Okay, then what is the I1? I1 is equal to total current into same capacitance 2 farad by total capacitance 2 plus 4 6. So that is nothing but 2 amps you are getting. Here the total current into same capacitance by total capacitance, here 4 amps you are getting. So total is nothing but it is the 2 you are getting, it is the 4 you are getting. That means here current is proportional to the capacitance. As capacitance is more, high current will be flows. Okay, high current will be flows. That means we know very well as Xc is equal to 1 by omega c. 1 by omega c. As C is higher, Xc is lower. As Xc is lower, then current will be flows more. More current can be flows. Okay. In the same way, coming to the resistor value, for example, let us take same here 6 amps current. R1 is 2 ohms, R2 is 4 ohms. Lower resistance, high current will be flow. So here maybe 4 amps current will be flow. Here maybe 2 amps current will be flow. If you want, you can also check. Okay, current will be divided as per the inversely proportional to the resistance ratio. Okay, the total current 6 into another resistor 4 by 4 plus 2 6, that is 4 amps you are getting. Okay, same 4 amps I have given now. Here also the total current into R1 2 by 6, that is equal to 2 amps. So here also 2 amps you are getting. Okay, so like that the current is divided as per the resistances, as per the capacitances values. Okay, the circuit reduction techniques problems. Okay, so these are very repeated problems. Okay, first of all we have to try the problem. After that I will explain, then check with my answer. Okay, so here in this problem they have given 1 ohm resistor, 2, 3, 4, 5, 6 ohms resistor. In the previous sessions, what we have learned, whenever any resistor is parallel to the short circuit, short circuit means zero resistance, then R into 0 by R plus 0, that is nothing but 0 only. So 0 resistance means again it is nothing but short circuit only. Okay, that means whenever any resistor parallel to the short circuit, note on the point, whenever any resistor or any element parallel to short circuit, it is eliminated. Okay, eliminated because of the current flowing through that resistor is equal to 0. No effect. That resistor has no effect. Okay, so that means we have to eliminate this resistance, and we know, we can also understand, if you send some current through this, here we have the resistance, here we have the short circuit, so that means zero resistance, current always takes the low resistance path, so the total current will flow through this resistance only. None of the current will flow through the resistance R. Okay, so then the effective resistance is nothing but 0, so we have only this short circuit. So from this, here 4 plus 5 plus 6 are nothing but 4 plus 6, 10 plus 5, 15. This 15 is parallel to the short circuit, so we can eliminate this 15, and 3 also parallel to the short circuit, we can eliminate this one. So 1 plus 2 only we have, so the answer is 3 only now. Okay, very simple. So 1 ohm, here 2 ohm, here 3, there is a short circuit here. Here we have 4 plus 6, 10 plus 5, 15. Okay, so this resistor and this resistor parallel to the short circuit, you can eliminate these two. Then RAB is nothing but 1 plus 2. 1 plus 2, that is nothing but 3 ohms. Okay, so the answer is nothing but 3 ohms. Okay, clear? So any resistor parallel to the short circuit eliminated, any resistor in series to open circuit also eliminated. I have given those points in the open circuit and short circuit concept. Okay, if you want previous, click on the playlist, you will get. And coming to the next one, next question, if they have given, the question is like this. Okay, here it is a 1 ohm. Here it is the 1 ohm. Here it is the 1. 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 Here also 1. Let us take it is A and B. Let us take it is X and Y. The question is find RXY. Find out RXY. Okay, come on, all of you try this one. And after that, check with my answer. So if you are going to find out the RXY, here there is no current will flow through this 1 ohm resistor, then it can be eliminated. It can be eliminated. And this resistor is parallel to the short circuit, it is also eliminated. Okay, then what is your circuit? 1, here 1, here also 1, here 1, here 1, here parallel to short circuit means eliminated. So we can write down like this. Okay, so now RXY is nothing but 1 plus 1, 2, 2 parallel to 1 plus 1 plus 1. Okay, so that means here you are getting simply 1, here also we have the 1, 2 parallel to 1. 2 parallel to 1 means 2 by 3 na? 2 by 3. Okay, so RXY is equal to 1 plus 1, 2, 2 plus 2 by 3. Okay, that is nothing but you can say 3 into 2, 6, 6 plus 2, 8 by 3. 8 by 3 is the answer. Okay, 8 by 3 is the answer. All of you clear? For the same question, if they are asking RAB, if they are asking RAB, if they are asking RAB, then what is the answer? If you are going to looking from these two terminals, this is the open circuit, this is also open circuit, there is no flow of the current through this, and bring out the terminals to outside. So if you are going to bring out the A outside, here you are getting, and here this resistance 1, okay, 1, and here at this point we have this resistor. So I am going to take this resistor, and here this resistor. This resistor is parallel to short circuit, you can eliminate that one. So you have like this. Okay, here this B, if you bring out the outside, you are getting the B here. Okay, so 1, here 1, here 1, here 1. So 1 in series with 1, that is nothing but 2, 2 parallel to 1 plus 1. Okay, so here 1 plus is 2 parallel to 1. 2 into 1, 2 by 2 plus 1, 3. So 3 plus 2, 5 by 3. Okay, you are getting the answer as 5 by 3. That is RAB. In this way, we have to find. So here, what are the important points we have learned? Whenever any resistor parallel to the short circuit eliminated, any resistor in series to the open circuit also eliminated. Okay. We are going to discuss a very important model, that is bridge type of problems. These are very repeated in the examination. Let us take one example problem. Let us take with us that is general example. Okay, any resistor you want. Let us take the bridge type of problem like this. The resistors are, let us take 1 ohm, 2 ohm, 2 ohm, 3 ohms, here 4 ohms, here let us take 6 ohms. Here question is find RXY. Here these outgoing terminals are X and Y. Okay, so X and Y. Okay, how to find out the RXY? Here these type of problems are whenever 1, 2, 3, 4, 5 resistors are connected like a bridge format, then there is a bridge type of problem. Bridge type of problem. In the bridge type of problem, the first step is nothing but we have to check bridge balanced or not. Check bridge balance or not. Okay, so we have to check bridge balance or not. How to check bridge balance or not? Our product of opposite arms is equal or not. So PQ is equal to RS or not. So 1 into 6 is equal to 3 into 2. Okay, so here 6 is equal to 6. So bridge is balanced. Bridge balanced. Okay, bridge is balanced. Here, whenever there is a bridge is balanced, then what is the key role we have? Here, the main important point is whenever the bridge is balanced, then voltage across these 2 points is same, then there is no current will flow through the inner resistor. So current flow through inner resistor is 0. So we can eliminate. So there is no effect. We can eliminate that inner resistor. We can eliminate that inner resistor. So we can eliminate 4 ohms resistor. If you eliminate the 4 ohms resistor, if you eliminate 4 ohms resistor, then the circuit is simply like this. 1, 2, 3 and 6. 1, 2, 3 and 6. Okay, X and Y. So 1 in series with the 3, 4 and 2 in series with the 6, that is nothing but 8. So now RXY is equal to 4 parallel to 8. 32 by 12. That is nothing but 4 8s, 4 3s. 8 by 3 is the answer. So RXY is equal to 8 by 3. Okay. Sir, you said is correct. Okay. That means if the bridge is balanced, then we have removed the inner resistor and we have solved the problem. But if the bridge is not balanced, then how to do the problem? Let us take that example also. Okay. Let us take that example also. Then you can get clear. Okay. So, for example, if the problem is like this, the problem is like this. Okay, here 1 ohm, 2 ohm, 3 ohm, here 3 ohms. Here there is a 3 ohms, X and here Y. Find out the RXY. Find out the RXY. Okay, so first of all, what is the step 1? We have to check bridge is balanced or not. 1 into 3 is equal to 2 into 3. So bridge is not balanced. Not balanced. Whenever it is not balanced, the second step is nothing but we have to convert delta to star. Okay, here we have one delta, here another delta. Better to choose the delta which having equal resistance. Okay, which having equal resistances. Okay, here upper delta 1 we have, lower delta 2 we have. Okay, in the lower delta we have equal resistors, so I want to convert this lower delta into star. This lower delta into star. Okay, so let us take that one. One ohm, 2 ohm. Here we have this star. Okay, X and Y. Here the star values. So we know very well R star is equal to R delta by 3 whenever the resistors are set. So 3 by 3, that is equal to 1. So this star value is 1, 1, 1. Now 1 plus 1, 2. 2 plus 1, 3. And 2 parallel to 3 plus 1. Rxy is equal to 2 parallel to 3 plus 1. Okay. So 6 by 5 plus 1. That is nothing but 11 by 5. You are getting the 11 by 5. Okay. So that means whenever bridge is not balanced, then we have to convert delta to star. Better to choose the delta. We have to convert into star, which is having equal resistors. Okay, equal resistors. Okay, I think here in the next type of the problem we have one voltage source. Okay, and we have the bridge type of the problem. Okay, X and Y given. Here resistors given 1 ohm, 2 ohm, 3 ohm and 4 ohms. Question is find RXY, the resistance between X and Y. Okay, first of all try to solve yourself. After that check with my answer. After that check with my answer. Okay, so first of all, if you are going to find out the resistance between these 2 points, here we have the voltage source. If we have the voltage source, how to find out the resistance? How to find out the resistance? Yes, we can easily find out. Here these are independent sources. Okay, let us make those are ideal. Okay, let us think those are ideal. We know very well in case of ideal voltage source, internal resistance is 0 na. So internal resistance is 0. 0 means the short circuit. Okay, so wherever we have the voltage source, we have to short it. Simple. Okay, in the same way, if we have any ideal current source, how to find out the internal resistance? Sorry, ideal current source internal resistance is infinite, that is open circuit. This is belongs to independent only. Okay, not dependent sources. Okay, applicable for independent sources only. Why? Because in dependent sources internal resistances are not 0, infinity. Okay, so here we have the voltage source, we have to short it. So I am going to short that one. Here we have 1 ohm resistor, 2 ohm, after this 3 ohm resistor, after this 4 ohm resistor. Here we have the X, here we have the Y. Okay, let us take this point as A and B. In the circuit reduction techniques, it is better to choose some points. Okay, if you indicate some points, it will be very easy. We have to find out the resistance between X and Y. So bring out the terminals as X and Y. Here X, here Y, here we have the A, here we have the B. Between X and A, we have one resistor. A and Y, we have one resistor. X and B, one resistor. B and Y, one resistor. That is 1 ohm, 2 ohm, 3 ohm and 4 ohms. Okay. Now, and one more. Between A and B, we have one short circuit is there now. We have to connect that short circuit. Don't forget. We have to connect that short circuit. Okay. Connect that short circuit. Now, the circuit is very easy to solve. Okay. Now, if you send some current, what is happening? Current is dividing. 1 and 3 are in parallel. Okay. After that short circuit. So, if we have the wire like this, if you reduce the wire, so you are getting one point. Point means series na. Find means series. So let us understand that one. Here what is you have here? This is the X. Here we have the resistor. Okay, that is connected to the point A. Short circuit means here point A means here also point A only. Okay, same points you are getting. So these three also connected to same short circuit. This is the short circuit you can consider. 1, 3. After that you have 2 ohms and 4 ohms are parallel. So let us take 2 ohms and 4 ohms are parallel. Okay, clear. So that means 1 parallel to 3. It is a short circuit means always make as plus. 2 parallel to 4. Okay. So series means you have to add. So 1 parallel to 3. 3 by 4. 2 parallel to 4. 8 by 6. Okay. That is the answer. Okay. That is the answer. You can solve the answer. That is not a matter. Okay. All of you getting how to solve whenever we have the voltage source to finding the resistance. Okay, whenever there is a voltage source, short it. If we have the current source, open it. Okay, if we have the current source, open it. Let us take that type of problem also. Okay, then we can get easy. We feel very easy. Okay, so let us take that type of the problem. These types are very important and also useful in case of Thevenin's and Norton's theorem to find out the RTH or R Nortons. Okay, in that also these type are very repeated. Okay, here 1 ohm, 2 ohm, 3 ohm, 4 ohm. Let us take some 10 amps or any amps, whatever you want. Here we have the two terminals A and B. Okay, find resistance between A and B. I have already given the hint now. So first of all, pause the video and try yourself. After that, check with my answer. Okay, that is the learning method in networks. So here we have open circuit. Sorry, current source. We have that is a open circuit. Okay, because we have to replace with internal resistor. We are finding the resistance means this one also we have to replace with a resistor only. So it is a open circuit means infinite resistance. Okay, so we have to open that one. So whenever we open that one and bring out the terminals to outside, here we have the A, here we have the B. Okay, and from A we have 1 ohm and here 1 point. Here we have the 2 ohms. After that, here we have the 3 ohms. Here we have the 4 ohms. Okay, all of you clear? I have opened this one. If you open this one, this wire also open. Now, if you send some current, what is happening? The current is flowing through 1 and 2. So that means these two are in series, that is 3. These two are in series, that is 7. Now 3 parallel to 7. Okay, so you are getting upside 3, downside 7. So 3 parallel to 7 means 21 by 10, that is 2.1. That is 2.1. Clear? Clear? Like that we have to do. So if we have the voltage source, start it, current source, open it. Okay, these are the two methods. In the next session, we will discuss the remaining methods, and students